All right, welcome everyone. I think we're ready to start today's class. Online people, like usual, please flag in the chat if the audio is bad or if there's some other thing that you're having trouble with, if you can't see anything along those lines. And for the online people, yeah, no countdown timer today, unfortunately. I wasn't as early as I was hoping to be, so it came from just a meeting right before this class that was an important one, so couldn't really shirk my responsibility there, unfortunately. Not unfortunately, I guess, I don't know. So we're starting a new unit today on cannabis. They're hopefully just opened a new quiz. People seem to be in it okay. There's 9 questions on this, and I did a bit of a survey, not a survey, like a analysis of all of the questions I've given you so far. And with this unit, when we're finished it, which we may finish today, we're up to 83 questions. So remember what I said at the beginning with these quizzes is they're all going to be worth slightly different amounts based on the number of questions that's on each quiz. So my initial plan in my head was to have each question worth 1 point or 1% of the thing. So now that we're nearing 100%, and I guess we're kind of nearing the end of the course too, it's all kind of coming together. I've been extremely busy the last, I'd say, 2 weeks or so. So I apologize. I know there's a few emails that I've still yet to answer, and I have them flagged. I plan to use tomorrow and dig myself completely out. I'm hearing the audio is a bit low. I can make that maybe a little louder. I don't want to go into robot mode here. So basically where we're at then, so if you've sent me an email, I'll get back to you. I think most of the emails, just as a quick cursory look, we're asking for extensions to these assignments, and I think we'd already talked about this a couple times. No assignments, unless there's like some crazy circumstance, in which case please send me an email, but I do plan to dig through all of those. I've been getting lots of questions about assignment 2, which is good, and I think I've answered all of those so far. Lots of good ideas, already starting to see them roll in. One thing I just wanted to highlight is I put up kind of like a little survey Dropbox thing on our website that I emailed you about on Tuesday. The purpose of that, there's 3 questions. The first one is list everyone who's in your group. The second one, and it can be just you, it doesn't have to be more than one person in your group. Second, paste the link to where your video is hosted, and it can be YouTube, it can be TikTok, I think somebody asked. It could be anything, doesn't matter, as long as it's accessible by me. And what I'm planning to do is take some of these videos and post the links that you're uploading to me and put them on our course page so everyone can see them. If you don't want that to happen, there's a question 3. So question 3 is any special requests around this video. So it can be, don't show it in class, it could be anything else that, I can't think of anything else you might want to put there, but who knows, maybe you have something that you wanted to mention there. So hopefully that's clear. Another thing I'm working on is a bit of a study guide, which is kind of, the way I do this, it's like a condensed list of questions for each unit that are open-ended. They're not multiple choice like the ones you've been getting all semester. They are, what is blank? With no solution provided, and I will not be providing solutions. So the idea is if you can go through all of those study questions and give good whole answers to each of those, you'll be very ready for the final exam. It'll give you a sense too of what details in each topic I consider to be important and worth knowing. So as an example, like in that unit we did on the history of chemistry, I will not be asking any questions like, what date did so-and-so discover the periodic table, or what date, like little fine, picky details, although maybe what I consider a fine, picky detail versus an important concept may not be the same as what you consider to be a fine, picky detail versus an important concept. So that's why I'm putting this kind of guide out, which will give you something to work from, I think, when studying. The final exam is going to be multiple choice, probably a minimum of 100 questions, maybe more, depending on how things look when we get there. And it'll be randomized, meaning everyone will not have the same exam. There'll be a big group of questions, and you'll get a random selection of questions from that group. And so the purpose is to make it a little bit more difficult for people to copy off each other. Not that anyone in this class would do that anyway, but hey, we've got to make it not that super straightforward and obvious. Will I make all the quizzes available for this final exam? Yes, I'll absolutely do that. So what I can do is make copies of all of the quizzes and make them all worth 0. So that way you can answer them. Can you not access the ones that have already been completed? Can't see them? No, okay. So yeah, I'll do those, and I'll try to set them up so that, or another thing I could do is maybe just make one giant review test and put all of the questions in there. That might be less work than trying to do them all. Yeah? Oh, you can still see them? You can't? Oh. Okay, maybe there's some setting I can just change and make them all visible after they've passed. Anyway, I'll do something. I'll make sure that you have access to those questions in some form or other before the final exam. We have a date now for the final, right? I don't remember what it is, but it's 17th. That's pretty early. Last day of class is the 13th, which is a Tuesday. So what does that mean? Is that a Saturday? Saturday at 7 p.m. Wow. Will the exam be on Acorn? Yes, it will. Yeah, it'll be an Acorn exam. So yeah, was anyone here, somebody must here have been in one of the classes in the fall when Acorn died halfway through the exam? That was a fun time. My exam was that evening, and it was back up in time, but freaked people out a little bit for sure anyway. Okay, I think we are doing good. Just remember that you have 13 days or so to get the final project done, link submitted. Even if you've already emailed me your link, post it anyway on the quiz, on the questionnaire thing. I just want to have one place I can go and make sure that I don't lose something in my email, because I'm getting lots of emails nowadays. Okay, so we're going to start our new unit then, which is on the chemistry of cannabis, which is, I guess, like, it became legalized, what, like 2 years ago? 3 years ago, something like that. So a lot of the research on this has been pretty sparse up until fairly recently. And I'd say the state of research now, a lot of it is still very preliminary, but there is a lot that we do know. And the thing I like about this unit, I guess, is that it's something that we can really apply chemistry to. That a lot of the concepts that we've learned already, we can apply to this particular subject. Okay, so what does cannabis actually do? Well, there exists in our body receptors, which are biochemical structures which elicit some biological response when they come into contact with a molecule that fits into the receptor. And so we have all kinds of different receptors in our body that are sensitive to a whole bunch of different chemicals. Maybe a really straightforward example would be taste buds, which would have receptors for sugar, or that would be a sweetness receptor. And we have other receptors that are sensitive to sodium, which makes things taste salty, for example. Well, in our body, we have two types of receptors called cannabinoid receptors. And these are called CB1 for cannabinoid 1 and CB2 for cannabinoid 2. And these are just receptors that are connected to typically our neural system. And these are ones that are specific for a class of molecules that we call cannabinoids. And cannabinoids are many, varied in structure, and these are the ones that would impact these particular ones. So there's two kind of main types. There's the CB1s, which are, generally speaking, found mostly in our brains, in our spinal cords as well. And then we have the other type, which is CB2, which is typically found mostly on immune cells. So there's kind of an immune receptor that can be modulated, the activity can be modulated by cannabinoids. Now, the molecules themselves that can actually interact with these receptors, we generally speaking call them cannabinoids, which makes sense. There's cannabinoid receptors, and there's the cannabinoids, which are small molecules themselves. And then we have a type of cannabinoids called endocannabinoids. And these are cannabinoids that are naturally produced in our body. And these are two different ones. There's one called anandamide, one called 2-AG. These are naturally produced in our bodies, and these are part of a sort of a natural regulatory system where these are produced by the body, and then these activate those cannabinoid receptors. And those cannabinoid receptors will impact the tissues or cells that they are attached to. So for example, the ones that are attached, the CB1 receptors that are attached to the brain and the spinal cord, those typically, they can regulate a lot of different biological activities. One of those is hunger. So how hungry we feel is in part a function of how these receptors are being activated. So I know some people say, like, you know, we have these cannabinoid receptors in our body, therefore that's proof that we're supposed to be consuming cannabis. But it's not true that our body has its own use for these receptors, and that, you know, it produces chemicals which interact with them. Yeah. So some of these receptors, sometimes they're called pleasure receptors, because there are certain pleasurable activities which lead to a release of endocannabinoids which activate these cannabinoid receptors. So in anandamide, apparently we get a boost of this in our system after we eat chocolate. So it's one of the biological responses of chocolate that I guess makes us feel good. So if you're sad, you can go eat chocolate ice cream. And although I guess chocolate ice cream actually doesn't have a lot of chocolate in it. Those 70% chocolate bars do, though, right? We talked about toxicity, but you know, you have to eat a lot of them. Is the exam going to be open all day on the 17th or just from 7 to 10 p.m.? I haven't decided that yet. I probably won't have it just 7 to 10 p.m. And the reason is because that's late in the day. And especially if you are in a different time zone. Like, I guess it wouldn't be so bad if you're in BC, but if you're in like Europe, I don't know if we have any people here from Europe, but yeah, I don't want to make people get up in the middle of the night. I'll figure something out when it comes to that. So cannabinoids can also enter our body through, I guess we could say, artificial or unnatural sources. By here, I just mean they're not produced by our own body. They're produced by something else. They can be produced in a lab synthetically. They can be produced in a plant. But whatever it is, these enter our body from some external source. So in cannabis, cannabis contains a whole variety of molecules that are considered cannabinoids. But there's one in particular, or actually two in particular, that are responsible for the effects of THC that most people use it for, the effects of cannabis most people use it for. And the main one is called THC, tetrahydrocannabinol. And it has this structure that you see right here. It's the main psychotropic chemical that can be found in cannabis. However, it only makes up about 1 to 2% of the dry weight of the marijuana plant. The other chemical, which is actually more important, which you may have never heard of, is called THCA, which is THC with this additional group here. That group is called a carboxylic acid. So we call this tetrahydrocannabinolic acid. So it's the oic acid is added to the end because that extra group is there. So this is actually far more prevalent inside the plant, and you can have plants that are up to 25%, the dry weight is this THCA. So this THC is the more important contributor to the psychotropic effects of the cannabis plant because it's present in such a higher amount. So what we often do for a cannabis or cannabis product, and you sometimes can see this on packaging when it's being sold, is it gives you a measure of something called total THC. And a total THC is made by combining the amount of this THCA, the THC acid, and the straight up THC that's present in the plant. Okay. So it turns out THCA, which is the major cannabinoid in the plant, is not psychoactive, And actually, if you eat the plant and you absorb it into your body, it doesn't really have any biological effect. So sometimes they call it devil's lettuce. You actually can't eat it like lettuce because the majority of, well, you can eat it, but you won't get the psychoactive effect from it by consuming it, because the major cannabinoid that's in the plant doesn't have any psychoactive effects, that THCA. And the very small amount of THC, I mean, I guess you could eat a lot of this stuff, but why would you? So what they do instead, actually, is typically the way cannabis is consumed is heating it first, either by smoking or vaping or baking it into something. It must be heated before you get really the full effect of it, because what happens when you heat it is this THCA gets converted to THC. So that's why we call this total THC, because the THCA becomes THC as it's being heated, and it's the combination of the both of them which makes the potency of the plant. By the way, sometimes we use a little triangle to denote heat when you see a chemical reaction like this. That little triangle actually comes from the ancient Greeks when they had the 4 elements. Remember the 4 elements were earth, water, fire, air? And fire, a triangle was the symbol for fire. So we still use that. We don't, well, I guess you could use fire in this example if you're smoking it. Okay, so the way they actually do the calculation for total THC on a package is they take the percentage of the product, the dry weight of the product, that's THC, they take the percentage, the THCA, and multiply it by this factor 0.877. And the reason they do this is, I think I have it here somewhere. Yeah, I do the math over here. So why don't I wait a little bit and do the math later? And so when you see a product like the one that I'm showing you here, you can see there's a measure of total THC in the product there, which is derived from the THCA and the THC that is present in the product, according to this formula. And I'll go through where that formula comes from and why THCA is counted less than THC in that formula. All right, so this is just a plot where they're showing the cultivation of cannabis. And this is actually becoming a new industry in Canada. I believe NSCC has a program in cannabis cultivation. And typically what people, obviously they're growing it for the THC/THCA content in the plant. And there's a whole lot of science really that goes into growing it in a way that maximizes the concentration. So for many years, there's been a lot of selective breeding of plants to produce more and more. So the cannabis plants that are available today have much higher potency, much higher concentration of cannabinoids than ones may have 40, 50 years ago. Also, the techniques of how they're grown have improved as well to increase these amounts. So this is just showing, if you grow a plant, how much THC and THCA are in the plant based on how many weeks old the plant is. And you can see it reaches a maximum sort of around 11 or 12 weeks after. This is probably under ideal conditions in a greenhouse or something like that. And what you can tell is that, you know, at the peak point here at 11 weeks, the yellow part at the bottom is just the THC content of the plant, and the blue is this THCA content of the plant. So yeah, you got to let it go. Once it flowers, you still have 5 weeks to go to maximize the content. So when you pick it, when you cultivate it, all of that matters when it comes to THCA and THC content. Okay, so what happens is when you heat this thing up, when you smoke it or heat it in some other method, what happens is this group comes off and it actually releases a molecule of carbon dioxide. So this is a chemical reaction we call decarboxylation. I guess we can write that down. Decarboxylation. D means something is being removed or without. Carboxyl is the carbon dioxide. It's kind of a chemical term for loss of that group. and then ation just means it goes. And so what happens is that COOH group is gone, and you're left with a hydrogen in that position where it was. So why do we have this number? Remember, it was like 0.877 times the percent of THCA plus percent of THC. It's because the molecule of THCA weighs more than a molecule of THC because it has extra atoms. And we can count up the atoms that are present in the molecule, and we can say, 1 mole, remember that number we looked at, Avogadro's number? 1 mole of that is 358.5 grams per mole. And once it undergoes decarboxylation, it loses 44 grams per mole of CO2, and it leaves behind THC, which weighs 314.5. So the mass of this one, just because it weighs less, is 87.7% of the mass of this. Okay, so that's why when we're doing this calculation of total THC, you take the THCA and you multiply it by 0.877 to account for the fact that the THC you get isn't the same mass as the THCA that you start with, because you lose some mass. So the THC you get is only 87.7% of the mass of the THCA you began with. Great. So notice if you add the grams up on both sides, they are equal to each other, which is a nice confirmation, I guess, of the law of conservation of mass by Antoine Lavoisier back in 1773. Good to see that still holds, which it does. And this is just going through that calculation once more. Let's start out now with a couple of questions. The first one, what are endocannabinoids? Compounds that counteract the effects of cannabinoids, small molecules we take in from our environment that activate CB1 and CB2. Receptors that interact with cannabinoids are small molecules naturally produced in the body that activate CB1 and CB2. The answer here is D. Endocannabinoids are the ones that are naturally present in our body. Second, what two compounds make up total THC? It's THC and THCA, which is C. Some of these other ones we'll talk about a little later. THCB I don't think is a thing. The A stands for acid in THCA. Third question, where does the majority of THC in marijuana smoke come from? It's from the THCA converted to THC as it's heated. It is present in small amounts in the plant before it's dried and after it's dried, but it's mostly the converted THCA that's giving rise to the THC content of the smoke. Okay, so there's multiple different ways that people choose to consume this. There's edibles. That's one way. You can smoke it in what's called like a cigarette. You roll it and you smoke it. Or you can heat it up in a device, which will put it at a high temperature. It'll vaporize it, and then you can breathe in the air from the vape. So there's different ways of doing this. Just an idea, the vaporizers that you can get will heat it, and you can set the temperature that it heats to, depending on the device you have. But typically it goes anywhere from about 180 degrees Celsius to about 220 degrees Celsius. It's pretty hot, you wouldn't want to touch it and burn you, given that water boils at 100 degrees Celsius, so it is pretty warm, but it's nowhere near as hot as a flame. So combustion will heat it up much, much hotter to around 700 degrees Celsius. So there's a big difference in how hot the cannabis plant is brought to when you combust it versus vaporizing it. So you can get, I guess, e-cigarettes now, which has, an oil, a liquid in there with the THC already in it, and then that'll just be vaporized and you can breathe that in directly. Or you can get these little portable vaporizers where you can take the dried cannabis leaves or cannabis plant and you can put it in and directly heat it up and inhale after it's been heated. So this is what I mean by vaporizers, that they can be portable. I've actually never seen one of these before, but maybe people have these. I don't know. Anyone ever see one of these? It's called a Volcano. And the idea is you put the dried plant inside, and then you kind of screw the top on, this bag on the top, and this will heat it up to a predetermined temperature, and it'll fill, like, you know, the gas will come and inflate this bag. And once it's done, you take the bag off and you breathe in the smoke from the bag. So yeah, I don't know if these are popular. I've never seen one before. But the reason I'm talking about it is because this is actually, one nice thing about this is it gives repeatable results. So a lot of the studies that have been done on the content of cannabis smoke uses one of these machines because it gives a repeatable result each time you do it. More or less repeatable result. So it's, the idea is, you know, you start with your raw material, it goes into the machine, and it produces vapor, which inflates the bag, and roughly 54% of the THC, total THC that's in your initial product, ends up in the vapor inside the bag. So you lose about half. Then when you breathe it in, roughly 65% enters your bloodstream, and 35% gets exhaled back out. So in total, that leads to about a 35% conversion of the THC in the plant to the THC inside your system using this particular system. If you want to get an idea of how much of the THC, you know, in the actual product ends up in your body, it's roughly a third using, under optimized conditions, using something like this. So in a paper that came out in 2009, what they did is they looked at the composition of the smoke coming out of this Volcano machine, depending on what the initial set temperature was, and compared that to like a cigarette, like just straight up smoking it, which is around, as we said, around 700 degrees. And it's actually quite interesting, and you know, the same data as in this table, which you see in this slide, the total yield is this black line of total mass or material that made it into the gas phase using the different methods. And what we see is the Volcano at 170 had the lowest, more if you have a higher temperature at 200, significantly more if you heat it up to 230, and all of them are less solids, you know, less material in the gas phase than burning it in a cigarette form. But maybe what's important here is the THC, because that's really what people are after when they're doing this. So the THC is this line here, and notice the THC that's transferred is actually really minimal at 170 degrees Celsius. However, if you jump up to 200, it goes up pretty substantially there. And at 230, you get way more THC in the gas phase inside the vape, inside the Volcano, than you do at either of the lower temperatures. So increasing the temperature certainly increases the conversion and the amount that ends up in the gas. What's interesting here is that the cigarette actually produces less THC than the vaporizer does at 230. Somewhere between, let's say, 500 and 700 degrees Celsius. So actually, burning it, even though you get way more total solids, it actually delivers less THC. And that's bad because everything else between here and here, all the other solids that are coming out here, is mostly junk. Like soot, like PM 2.5 we talked about, tar, other negative things which are associated with you know, negative health effects, and not at all producing any of the desired effects that people are typically using this product for. So this is, I guess you could say, this part here is the crap. So you get certainly some crap at the 230 degrees, but not anywhere near as much as you do from just straight up smoking it. So in terms of maximizing the amount of THC you get and minimizing the amount of the garbage you get, probably the best overall picture here is the vape at a high temp. Another actually interesting aspect of cannabis use and cannabis chemistry is the pharmacokinetics, which basically just means when this enters your body, what happens to it, what are the time scales involved, how long does it last, how long does it take for it to disappear, how long does it stay in your system. And these of course will vary somewhat person to person, but this was a paper, quite an old one now, back in 1992, where they had people take in THC through some source, typically by smoking, I believe, in this particular example. And what they were doing then is taking blood samples at various periods of time and measuring the amount of THC that was in their blood. So what they found is, time 0 is when, well, between time 0 and time 2 was the period where the cannabis was being smoked. And notice you see this big spike in THC concentration in the blood. Once the smoking has stopped, which is basically around that time, THC levels stop rising, which makes sense because you're not taking it in anymore. But the THC levels, you can see, very rapidly drop off. They drop off exponentially, and the half-life, T1 half is what we sometimes use here, is around 15 minutes. So that means if you ingest THC, if you take in THC, not ingest, if you inhale THC, it gets into your bloodstream, your body actually very, very rapidly converts it into something else, takes it out of your system. It only lasts in there for a half-life of 15 minutes. So THC does not linger in your system really at all. What happens is it gets acted on in the liver by a molecule called cytochrome P450. And this is an enzyme which basically takes your THC and installs an OH group up there. Why does it do that? Well, one of the main functions of your liver is to detoxify anything that's in your blood that it thinks shouldn't be in your blood. And the main way that your liver detoxifies things is it adds OH groups to things, or it sometimes adds sugars, or it adds other things to, and the purpose of doing this is it makes the molecule more water soluble. And the more water soluble the molecule is, the easier it is for your kidneys to filter it out of your blood and excrete it. So it kind of works hand in hand with your kidneys to make these molecules more water soluble. And as we know, adding OHs to things makes them more water soluble. Now it turns out THC is psychoactive. This product, this 11-OH THC, is also psychoactive. So if you consume cannabis and you get high, your high actually after the first half hour or 15 minutes or whatever is not actually THC that's creating that high, it's this metabolite. Metabolite is a molecule that is produced because of the metabolism of a different molecule in your body. So it's converted into this form, and this is the one that typically lasts a much longer period of time in the body. This is continually reacted in your body, again, I believe, by cytochrome P450, and it further oxidizes that position with the OH on it to a carboxylic acid. So it puts a carboxylic acid on the molecule, that makes it even more water soluble, and that is the one, the final form, if you will, right? It's kind of like, I know nothing about Pokemon, really, but I just know that there's like evolution, and they go through steps, right? Maybe. So anyway, this is the final form. This is called THC COOH because this group here is a COOH. This is 11-OH THC because it's THC with an OH on carbon 11. All these carbons are numbered in this particular molecule. So we know actually quite well what happens with this. So in terms of timeline, THC, you get a big spike initially when you first get it into your body. It disappears with a half-life of about 15 minutes and gets converted first into this 11-OH THC. So this concentration grows while the THC concentration decays. And then this decays itself over the period of hours. This is units of hours here. So, its half-life is around 2, maybe a little bit longer than that, 2 to 3 hours. In which case it gets converted to THC COOH, and then this grows in as this one, the 11-OH-THC disappears, and then this kind of drops off, and notice how long this lasts in your system. It's like, tens of hours. So basically days, right? Like at 120 hours, that's like around what, 4 or 5 days later? There's still detectable quantities in your blood. And if you work at a place that does drug testing, or you're an Olympic athlete and they do drug testing and they want to search for marijuana, they don't look for THC, they don't look for 11-OH-THC, they look for THC-COOH because that's the metabolite that hangs around longest in your body. THC-COOH, I don't believe is psychoactive, so you'll have no high or no effects of that compound in your body. It just takes a while for that to be filtered out by your kidneys and rid your blood out of it. I don't know how long it's actually detectable for. There's probably methods that are sensitive enough that might be able to detect it like weeks after the initial dose. But yeah, I'm not sure. I got some confirmation in the chat about Pokemon. So there's usually 3 forms, but some have 2 and some don't evolve. Okay, that's good to know. I do know Pikachu is one of them, and I have Super Smash Brothers at home. I play with my daughter sometimes. So Jigglypuff, is that one of them? Jigglypuff might be from another franchise. I don't know. Edibles actually is a different story. Edibles, it's quite a bit different. This is showing the time of concentrations of THC, THC 11-OH, and THC-COOH in the body after consuming oral edibles. And I believe the way this was done is they took 2 edible doses 10 minutes apart that were 2.5 milligrams each, which is a pretty low dose, and they was dissolved in sesame oil. So it was just kind of like you take a little, I don't know, it's sort of like drinkable, I guess, as opposed to edible in that particular case. But this was done back in 2003. You can understand why this research can be sometimes difficult to do. But what they noticed is that the THC, there was a bit of a delay after you first take it. The THC only kind of slowly came up, and it only was present in relatively small amounts. So there was this onset, right, of more than an hour before they started to see it in the blood in this particular trial. And as this was being generated, you can imagine, or as it was being absorbed, it was also being processed very rapidly back into 11-OH-THC. So 11-OH-THC actually kind of precedes it, the THC, because the THC, in the first 2 hours, the THC that was being formed was also being already converted into the 11-OH-THC. This then increases over a period of, like you can see this, around 10, 20 hours. And then you see the 10-THC-COOH. And notice the scale here is much higher. The scale on the right is the numbers for the THC-COOH, and on the left is for the THC and the 11-OH-THC. And that one grows and decays over a much longer time span, certainly many tens of hours. So this is actually an interesting study. What this shows, I guess, generally speaking, is that edibles are kind of like a slow release method of getting THC. You don't get that quick, sudden increase, that jump that you get by inhaling. And this is actually true with many different substances, that if you breathe something in, it typically can enter your bloodstream much more rapidly than if you ingest it. Okay, because it gets into your stomach, it has to pass through membranes in your stomach to get through. It would probably depend on if you have a full stomach or not a full, dissolved in, or all these other kinds of factors as well. So, don't take any of these numbers as being, just take them as kind of ballpark figures. Plus, individuals will vary, right? Depending on your particular. I'm getting an invite to go play Super Smash Brothers. I can play online too, probably. I'm really bad at it. I just mash all the buttons and then try not to fall off. Like 90% of my deaths in Super Smash Brothers are from falling off the edge. That's tell you my level of ability there. Which cannabis consumption method delivers the highest amount of THC? Smoking, eating, high temp vaping, low temp vaping. So when I say eating here, I don't mean edibles, although eating is sort of edibles. What I mean if you had just the straight plant, okay, like not prepared in any way or turned in. Use Kirby if you're a noob. So I do use Kirby because I think he floats up. So he's the easiest not to die. The answer here is C, high temp. What is THC first metabolized to once it's in our bloodstream? So it goes THC to 11-OH, THC, finally THC, COOH. Sometimes the dash is there, sometimes it's not. So the first thing it's metabolized to is B. Not BPA, that would be weird. What THC metabolite remains in your system for several days? That was D, the THC, COOH. That's the final form, right, in your metabolism process. Cool. So edibles, I guess, is the whole other topic. The other probably most popular way to consume it. In fact, I don't know. I guess it's technically possible to inject, but that's pushing it, I think. So remember what we have to do. To make the THCA into THC, you have to heat it to lose the CO2 and turn it into THC. So it turns out THC is not a very polar molecule. It has an OH, which gives it hydrogen bonding, but the OH is sort of a small part of a much larger molecule. So overall, THC is a pretty non-polar molecule. For that reason, it has a very low solubility in water, and this actually creates a big problem for making various food products using this particular material. So for example, there's a lot of effort being done now to try to come up with beverages that contain THC as kind of an alternative to alcoholic beverages. But the problem is that like you can't get the THC to easily dissolve in water, and what it'll do is it'll all float to the top and you get this kind of layer of THC scum along the top of the drink. So I guess you could theoretically at least make like a tea. I'm sure it would taste terrible, but you technically could, but you'd have these little oil droplets at the top. Kind of like you see when you have soup sometimes, the fat will rise to the top and you get these little droplets on the top. So it doesn't like to dissolve in water. It's hydrophobic, but it actually has high solubility in other materials that are also nonpolar, like nonpolar liquids, nonpolar solvents, or fats and oils, which are also very nonpolar. So to make THC, first of all, from the cannabis plant, you first have to heat it to turn the THCA into the THC, separate it from the rest of the plant, all the solid material, and this can be done by extraction into something that's nonpolar. This is the common way to get the THC out. And it turns out that a perfect nonpolar substance that can both heat the cannabis and extract out the THC is butter. And so a common way of starting out making edibles, if you just have the pure plant, is to put it in a pot with butter, boil it, like heat it up. You probably want to get it to 200 degrees or so. Maybe not quite that hot. Maybe you don't want to burn the butter, obviously, but you want to make this quite hot. And typically people will leave this for hours, like maybe 1 or 2 or 3 hours. So the longer you leave it, the more THCA to THC conversion you're going to get inside this pot. So you can't just heat it up and then stop and then expect to get much yield. So you need to convert that over as much as you can. The second piece that happens while it's in there is you're extracting the chemicals themselves from the leaves and the other kind of just dry organic material that's present. Then you can filter it through cheesecloth or something like that and pour over, and you see this kind of yellowish, kind of olive looking color material. And then when you cool that back down, you get butter, which contains the THC. And then you can use that butter to make cookies or whatever you want with it, which will have the THC in it. So it won't work unless you do the heating step first, which is important to do the conversion of the THCA to the THC. So however you do it, you need to make sure that it's heated. And the cooler the temperature you're heating it at, the longer you have to heat it for. Industrially, the way they do this, so if you buy THC edibles, the way they do this industrially is they use these machines which use supercritical carbon dioxide. So what happens, this is something that we call a phase diagram. For CO2. And what this shows is under what conditions of pressure and temperature CO2 will exist in different phases. So if you are under very high pressure and low temperature, you're up here. And this, we would say, if you're at any, you can put numbers on this scale if you want, but this is pretty general here. But generally at high pressure, low temperature, it's going to be a solid. At low pressure, high temperature, you're out here and you're a gas, you're a vapor, and kind of intermediate between so medium pressure, medium temperature, you can have a liquid. And CO2 liquid you may not have heard of or seen before, but you can get liquid CO2 in cylinders, or sometimes you have big tanks like on trucks being pulled that are full of liquid CO2. But it turns out if you heat up CO2 enough, we have a point here we call the critical point, that if you heat it up above that point and put the pressure up higher than that pressure indicated by this point up here, we generate something we call a supercritical fluid, which is kind of like a new phase of matter. And it's this phase out here. And what happens in a supercritical fluid is you have carbon dioxide molecules cluster together. So they form little clusters, but those clusters are well separated from other clusters. So you can see these clusters are pretty separated. So they're like gases where there's separation between clusters, but they're also like liquids in the sense that each cluster itself you can think of as being like a little liquid droplet. And as a result, supercritical fluids are actually fantastic for extracting things. In fact, supercritical carbon dioxide is also used for extracting caffeine out of coffee beans. And so what these do is they'll dissolve inside those little clusters. They can dissolve nonpolar things, because CO2 is a nonpolar molecule, like THC, like whatever. And then to make it not soluble anymore, all you have to do is lower the pressure. And if you lower the pressure and you drop it below the pressure required to make the supercritical fluid turns back into a gas, and the THC will actually come out like snow. So you can have THC and you collect it out of the bottom, and you can then, that should be pure enough that you can then put it directly in some product afterwards. So this is used for THC extraction industrially. It's also used for caffeine. And the caffeine, you use it to make decaf coffee, but you can take the caffeine and sell it as well, because they add that caffeine to things like pop or energy drinks, or you can get caffeine pills and all this sort of thing. So yeah, supercritical fluid. This doesn't say anything that I didn't show you on the previous slide. Except I guess it tells you the pressure and temperature. You need to get to 100 bar. 100 bar is like 100 times higher pressure than atmospheric pressure. And you need to get above 300 degrees Kelvin. So that can give you your supercritical fluid. So then what you can do is, of course, take the THC and mix it in with sugar and make it into a candy or whatever, which is probably the most common. As I said, THC-infused beverages is area of active research right now. Because I guess, like, if you think about smoking it or vaping it, as I said, you get that maybe instant hit, but you also get all that garbage that comes along with it that you could avoid if you were able to consume it through some other method. Ethanol, like beer, which is ethanol in water, or vodka, which is almost pure ethanol in water. By pure, I mean like it's like 40% ethanol in water, but there's really very little else in there. Ethanol dissolves nicely in water because it has hydrogen bonding and very similar types of interactions between the molecules. But THC doesn't. It's hydrophobic, doesn't dissolve in water. The solubility is only 2.8 milligrams per liter. And when you think about it, like an edible, typically like one candy edible is like 10 milligrams. So to get the equivalent amount of THC from just saturated THC water, you'd need to drink 4 liters, which is a lot. So there are methods people use to try to jack up the amount of THC that you can dissolve into water. One method is using a chemical called brominated vegetable oil. And this is commonly used in the soft drink industry. What brominated vegetable oil is basically a vegetable oil, like a fat, with bromine atoms added on at various places along these long carbon chains. So it's a chemical compound made by subjecting vegetable oil to bromine, to molecular bromine, or Br2, and it turns into something like this. By adding the bromine, what you're doing is you're making the oil denser, and they keep adding bromine to it until the density of the oil goes down to be, or up, I guess, the density goes up to become the same density as the water. And what that does is if you put this in the water, it won't float to the top, it won't sink to the bottom, it'll stay evenly dispersed. And they use this a lot in things like Mountain Dew or kind of citrus-based drinks, Gatorade, things like that as well. Because what it'll do is it'll prevent citrus oils from rising up and going to the top of the liquid, which would be kind of unappetizing. It kind of keeps it blended in the middle. So you could use this. It can emulsify them, which means it'll keep them suspended in solution. And you could use this to make THC stay suspended in solution as well. That's one method that you could potentially use. There are some potential health concerns with using too much brominated vegetable oil, and I think that remains an area of active research. You can see Mountain Dew here has brominated vegetable oil as one of the ingredients, and that's what it's doing, is it's keeping the other oils, the citrus oils that are in there, from separating out and rising to the top. Another method which is actually being used, which is interesting, is making use of a class of molecules called cyclodextrins. And what cyclodextrins are these kind of ring-shaped molecules that kind of look like a bucket almost. A bucket with a hole in the bottom and a hole in the top, with one hole being wider than the other one. And what they're made out of is this kind of ring of sugar molecules, sugar units. Each single kind of segment here, you can see in this chain, is a glucose unit. And so it's just like a bunch of sugars that are kind of made to form into a ring, and it's got this sort of cavity in the center, and then it can freely dissolve in water. It's got OHs everywhere, so it can dissolve nicely in water, and it's got this sort of pocket in the middle, and the pocket is kind of hydrophobic, meaning water doesn't like to be inside. So what happens if you got to go to a little molecule here of THC, what it can do is go inside the bucket and then remain dissolved in the water. So the use of cyclodextrins is sometimes used in medicine to make certain drugs and things that are not water soluble dissolve in water. It can be also used for THC. And I believe there's some research going on right now at Acadia on using cyclodextrins for this particular purpose. So cyclodextrins are non-toxic. Once they get into our bodies will break those down into individual glucose units. So it's just like you're eating sugar, and they actually provide you with a little bit of energy, I suppose, in the form of calories. So there's different types of cyclodextrins based on the number of units. If there's 6 units, it's called alpha cyclodextrin. If there's 7, it's called beta. If there's 8 glucose units, it's gamma. And these, of course, have different sizes. The bucket, the whole shape gets larger as you add more units. And depending on the size of the bucket, it'll tell you how nicely the THC will fit inside. You want it to fit well, but not too well, because you want it to come back out eventually later on. So yeah, this is the idea. We have a host and we have a guest. You want the guest to go inside the host and form what we call an inclusion complex. So it turns out you can drive the solubility in water of THC from 2.8 milligrams per liter up to 14,000 milligrams per liter. That's a pretty big, increase in the amount that you can get dissolved in water. Now this would be like way too much, I think, for a practical application, but probably you could almost make like a concentrated syrup or something out of it and then dilute it as needed. A few more questions. What liquid would THC be least soluble in? So it's not soluble in things that are very polar, like pure water. It's more soluble in water with BVO, it's more soluble in water with cyclodextrin, and it's more soluble in non-polar liquids, such as ethanol. What phase of matter exists and at temperatures and pressures higher than the critical point? And that would be a supercritical fluid, as we just discussed. By the way, the software I was using to make these questions doesn't work on Big Sur, so that's why there's no images anymore on these multiple choice questions. I'm trying to fix that. What are cyclodextrins? They are ring-like compounds made of individual sugar units. Now, toxicity, I guess, is the last piece, or maybe risks associated with cannabis use. There's a myth going around about THC use that it's impossible to overdose on THC. And I just want to be very clear that there is no chemical on this planet that's impossible to overdose on. You can overdose on literally anything. You can overdose on water. Every single chemical has a toxic limit that we can't take in more than that. And I think this actually the reason where that myth came from is that people have been tracking causes of death from various purposes in the US for many years. And a publication came out, I believe it was in 1984, where they published causes of death. And up until 1984, there were 0 recorded cases in the US of overdoses due to THC. So some people stretched that. They said that because there have not been any overdoses of THC, it was impossible to overdose on it, which wasn't true, just nobody had overdosed yet. Since 1984, many people have. And so this is showing poisoning deaths. So this is people who would have crossed or surpassed their LD50 and died as a result in the US between 1999 and 2004. Notice the numbers are very small, 2, 2, 3, 2, 1, 2, 3, whatever. And then there's a big jump in 2011. I'm not sure what exactly happened here. Was that when THC became legalized in Colorado? I think Colorado was the first state to legalize it. I don't know what year that was. But certainly if the availability suddenly went way up, and especially availability of other forms like edibles that are easier to overdose on, that would also definitely explain where that jump came from. But it's definitely possible to overdose on it. So use it responsibly, like you should. Treat it like any other chemical that can have effects on you. It's especially an issue for children, where children have a much higher likelihood of overdosing because their bodies are not fully developed yet. THC is not measured in humans or hasn't been measured in humans. There's not enough data to really say for sure, but they do have measured it in other animals. The LD50 is 3 grams per kilogram body weight in dogs for oral consumption. So that means if you, I guess they couldn't convince the dogs to sit there and smoke it. Although I guess you could put a dog in a room and fill it with smoke and make them breathe it in that way, but they didn't. They fed it to them. And 3 grams per kilogram is actually a very high LD50. You know, that's way higher, probably way less toxic than drugs like ibuprofen, or I don't even know what the LD50 is for ibuprofen, but it's up a lot higher than that. So edibles, and these are one type of edible that you can buy. They're called Butterweed's Small Sour Keys. Each one of them is 10 milligrams of THC, which seems to be kind of like a standard unit for edibles. You would need to eat about 1,800 of those if you're 60 kilograms to reach your LD50 if we have the same LD50 as dogs. That's a pretty high number. So don't eat that many, please. It turns out for rats, actually, the LD50 is a little bit less than half, which means for rats, it's a lot easier to hit that toxic dose than it is for dogs. I will say that these numbers, they report them with the accuracy to 10 milligrams per kilogram. These numbers have an error bar around them. So it's, I say dog was 3 grams. This is, 1,270 milligrams or 1.27 grams. There's definitely error bars around that. There's some uncertainty around that. When they do these sorts of experiments, they want to minimize the number of animals that are required to get this number. And so they want to make sure not to obviously, kill more animals than they need to, really. So if we have the same toxicity or same LD50 as rats, which is actually more likely that the toxicity for us would be more similar to rats, because our endocrine system, we have evolved to eat an omnivorous diet like rats, not a carnivorous diet like dogs. So it'd be more likely that we have a LD50 in this sort of range. Still, that's around 800 of these 10 milligram edibles, which would be quite a feat, I think, to consume that many and poison yourself. Now, what I should say very clearly, though, is 10 milligrams are kind of the minimum unit that you can buy. And you can actually buy edibles that have much, much higher THC concentrations than 10 milligrams, which makes it much more likely that you could be in an overdose situation with far fewer than 800 of these consumed. So this is just one I randomly found online. They're gummies, and they're cast into these little shapes like Lego figures. Each one of them has 240 milligrams of THC. And 240 milligrams is 24 of those ones that were on the previous slide, right? So what is that, 8? So times 3 is how much you have in one of these. So then for that same 60 kilogram person to hit their LD50 on THC, this is how many? It's 32 of these high potency edibles that you'd have to take in. And, that might seem a lot, and obviously, hopefully an adult wouldn't do that intentionally, but it'd be very easy for a child to eat 32 gummy candies, or a person who wasn't aware what they were eating, or a pet that weighs a lot less than 60 kilograms. And so this is where the real issue is coming in with these, is ones that are whether you have people that are children or pets that are getting into them, or if they have higher potency than sort of the minimum that you often see. The other thing is that many manufacturers of these products deliberately try to make them look like actual candies. So this is one, Stoner Patch Dummies, has packaging that's almost identical to Sour Patch Kids. And it'd be very easy, because how closely would you inspect the package to rip one open and just eat the whole package, right? Makes them also especially attractive to children. If children come across them, they're likely to eat them too. This is just a CBC article from 2 months ago saying, copycat pot edibles that look like candy are poisoning kids, doctors say. And you hear about these cases every once in a while of kids getting into them. Usually the kids don't die, so usually they're not hitting their LD50, but they're often hospitalized, and occasionally they do die, of course. Consuming it by smoking is actually much harder to reach your LD50 dose, and that's because you can't absorb huge amounts of THC from smoking cannabis one joint at a time. So basically, to hit your same LD50, to intake the same amount that you would from edibles, you'd have to smoke like around 2,000 1-gram joints. That's 2 kilograms of marijuana you'd have to smoke in a short period of time. So it may be impossible to overdose on THC by smoking. This is 720, by the way, in this picture. So 3 times that is about the 2,000 you would need to overdose. So very, very difficult to do. Not impossible, like you can make one giant one, I guess, but 2 kilograms, that's an awful lot. As marijuana becomes more potent, actually, that number gets smaller, right? Because the amount that you could have in one gets smaller and smaller as time goes on. The toxicity is actually way lower for injection, 28.6 milligrams per kilogram body weight. That makes it, what, 40 times more toxic by injection, which I guess makes sense because when you inject something, you get all of it all at once, as opposed to oral consumption. It's a little more time delayed. By having it time delayed, what happens is the THC gets converted into those other forms, the 11-OH-THC and the THC-COOH. So please don't inject this stuff either. We've focused a lot on THC, THCA, of course, and that's, of course, the compounds that people are probably most interested in. But there are other cannabinoids that are present in the plant, and the one that probably gets the most airtime is cannabidiol, which is this particular structure. It's different from THC or THCA. It doesn't get converted from THC to THCA in the body. It's just a different cannabinoid that happens to be present in the plant. It's believed that this molecule, CBD, is responsible for many of the beneficial or medicinal effects of cannabis use, that it can be used to treat things like MS. Actually, you can buy a prescription for a drug called Sativex that actually is CBD or CBD oil. There's lots of different products that can contain CBD oil that you can buy. People use for all sorts of things. I don't know how effective they are for any of those things, but like muscle pain or things like that. It does not appear to have any psychotropic effects. So the idea is, I guess, is if you use this, you would be then safe to go drive or whatever else. It doesn't impair your cognitive function. So there you go. There's other ones in there too. This is just a little infographic, and I posted one that looks a lot like this yesterday for St. Patrick's Day on the Instagram page for Guinness and the chemistry of Guinness and the compounds that are in Guinness. This is just another one that's showing different types of cannabinoids that can be present in the plant. There's actually also efforts, chemists are trying to synthesize variants of THC in the lab that could potentially have much stronger effects than THC itself. So there's a whole bunch of sort of variants of THC and THC-based compounds, and there's a few different classes of them that are shown here. So for normal, I guess, use of cannabis, really overdose isn't a huge concern. You'd have to really work to consume enough THC to really risk hitting your LD50 and putting yourself into an overdose situation. Not saying it's impossible, but those really primarily aren't the main health risks. There's the health risk associated with smoking it, that you're inhaling particulate matter, tar, all these other things which will contribute towards respiratory disease, including cancer. But if you're taking it as an edible, that is not a problem. One problem that has been associated with it, though, is an increased prevalence of schizophrenia and psychosis among people who are heavy users of cannabis, THC. And again, this research is preliminary and growing, but it's been actually understood for a fair amount of time. One of the first studies was done as long ago as 1987, and they followed a group of 45,000 heavy users of marijuana in Sweden And this was sort of like an epidemiological case. So what they did is they looked at the prevalence of various diseases and disorders within this group and compared that to the general population and the prevalence of all those things. And what they found was that members of this group had a 6 times greater likelihood of developing schizophrenia. And they published this, and with the usual warnings, is this is a correlation. It's not providing a causative link. It wasn't clear from this paper if the marijuana use was causing people to develop schizophrenia, or maybe it's people who are pre-schizophrenic, is that even a word, are more likely to choose to become heavy users, right? It's not sure which one's the horse and which one's the cart, really, in that particular example. But there was a lot of follow-up studies since that time, and now there's actually a quite clear causative link between the two. Follow-up study with the exact same group of 45,000 users was published in 2002, and they found that moderate use, which they defined as using the drug 11 to 50 times over a 15-year span, doubled one's risk of developing schizophrenia sometime over that period. Heavy use, and I forget exactly how they defined it in the paper. I think heavy use was like 5 times a week or more, led to this higher thing. And in a recent paper in 2017, the author says, our research demonstrates the cannabis has a differential risk on susceptible versus non-susceptible individuals. In other words, young people with a genetic susceptibility to schizophrenia who have had psychiatric disorders in their families should bear in mind that they're playing with fire if they smoke pot during adolescence. So the idea is that there seems to be some people with some genetic predisposition, and they haven't worked out all the exact genetic triggers yet, but if it's present in your family, if there's a history of schizophrenia in your family, these people tend to be very susceptible to having their risk amplified by marijuana use, where others that don't have those genetic risk factors appear to not have an increased risk of schizophrenia, that they're able to kind of sort people into groups beforehand. And really the warning here is if you do have a history of psychiatric disorders in your family, including schizophrenia, you really are playing with fire here. And you could be increasing your risk much more than a factor of 6, because factor of 6 was over the entire population, right? So it could be much higher than that. Health Canada currently says that your risk of developing schizophrenia overall is increased by between 8 and 14%. I think was what the stats that they give now, if you start to use it. So I guess these numbers are increasing over time. Not just schizophrenia, though. There's all kinds of different mental health disorders which are associated with cannabis use. And sometimes these cause a spiral where certain mental health disorders will cause people to seek cannabis as a potential relief of symptoms. But there's an association between suicide, depression, and anxiety and cannabis use. So they find in a systematic review and meta-analysis, so what they did is they looked at 11 different papers that published data on this topic and combined all of the results into sort of a super study, which is what this paper was. Over 23,000 individuals combined in these studies found that cannabis consumption during adolescence is associated with increased risk of developing depression and suicidal behavior later on in life, even in the absence of a premorbid condition. So even if you didn't have any of these types of symptoms of depression or suicidal behavior before you started using. They said no association with anxiety in that group. So in the US, what that means is there's roughly 400,000 cases of depression solely attributable to cannabis use in the United States, or potentially attributable if everybody in that age range was using, based on the population of the US, the incidence of depression, and the number of people that fit into that particular age range. Another paper, which kind of shows the flip side, is that people who were heavy users of cannabis who stopped, there was a correlation of a mood improvement for females emerging adults. So they limit it to young people who were female. So there's a relationship between reduction in cannabis use and reduction in depression symptoms. This is all evolving. Like, this is all within the last 5 years, a lot of it. And as cannabis use becomes sort of maybe more accepted in mainstream society, the amount and quality of this research will only improve. So there may be things that we uncover in the next 10, 15 years that we're only sort of guessing at now as a result of this increase in study going forward. Because before you couldn't really easily do this type of study because the drug was illegal. So it was very difficult to get permission to do these sorts of things. Cannabis use was associated with negative long-term symptomatic and treatment outcomes across anxiety and mood disorders. This is just another recent paper. I don't see the date on this one, but I believe this one was since 2017. I think I have in the actual PowerPoint slides, the reference in the bottom. Is the date there? Yeah, 2018. There we go. So you're seeing more and more of these things come up. So our understanding of how this can impact is getting stronger and stronger. And what it seems to show so far is that the impact of THC is greatest on the developing brain. And that these sort of negative consequences and negative outcomes are mostly associated with people that are using it as young adolescents, typically before the age of 18, often before the age of 15 or 16 in many cases, while the brain is not completely fully developed. So the same sorts of risks would not be present if you waited until you were 30 before you started use. So suggests the early data. Health Canada actually has a nice piece here on cannabis use and risks, and they have actually different pages depending on your age range, what the specific risks might be to you. This gets constantly updated as these new studies appear and come out, and it's one of these things that every time I give a lecture on this, I feel like it's almost already out of date because there's so much that is being learned now. We're in the very kind of early days of this. But definitely if you are somebody who is a user of cannabis and you may be experiencing some of these things that we see on some of these slides, it may be worth considering whether your use of that may be contributing to some of the symptoms that you're experiencing. For sure. So that's where we're at. We are finished this. I promised it was going to be a short unit, and I followed through on that, hopefully. And we have a few more units to go. But we are moving along quite nicely, so I'm happy to see with how things are going. And that's it for today. So goodbye to the people that are here in person, goodbye to the people online, and we'll see everyone on Tuesday next week.